Good morning, class. Our lesson for today is electronic configuration. So, what is electronic configuration? The electronic configuration of an element describes how electrons are distributed in its atomic orbitals. Electron configuration of atoms follow a standard notation in which all electron containing atomic subshell with the number of electrons they hold written in superscript are placed in a sequence. For example, the electronic configuration of sodium is 1s raised to 2, 2s raised to 2, 2p raised to 6, 3s raised to 1. However, the standard notation often yield lengthy electron configurations, especially for elements having a relatively large atomic number. In such cases, an abbreviated or condensed notation may be used instead of the standard notation. In the abbreviated notation, the sequence of completely filled subshells that correspond to the electronic configuration of a noble gas is replaced with a symbol of the noble gas in square brackets. Therefore, the abbreviated electron configuration of sodium is Ne, which neon 3s raised to 1. The electron configuration of neon is 1s raised to 2, 2s raised to 2, 2p raised to 6, which can be abbreviated to He, which is helium 2s raised to 2, 2p raised to 6. Electronic configuration are used for determining the valency of an element, predicting the properties of a group of elements. Elements with similar electron configuration tend to exhibit similar properties. Interpreting atomic spectra. This notation for the distribution of electrons in the atomic orbital of atoms came into practice shortly after the Bohr model of the atom was presented by Ernest Rutherford and Niels Bohr in the year 1913. So, let's proceed in writing electron configurations. So, the shells. The maximum number of electrons that can be accommodated in a shell is based on the principal quantum number. It is represented by the formula 2n to the power of 2, where n is the shell number, the shell's values of n, and the total number of electrons that can be accommodated are tabulated below. Shell and n num value. K shell n is equals to 1. L shell is equals to 2. M shell is equals to 3. N shell is equals to 4. The max electrons in the electron configuration. 2 times 1 to the power of 2 is equals to 2. 2 times 2 is to the power of 2 equals to 8. 2 times 3 to the power of 2 equals to 18. 2 to the power of 2 times 4 to the power of 2 is equals to 32. Subshells. The subshells into which electrons are distributed are based on the azimuthal quantum number denoted by I. This quantum number is dependent on the value of the principal quantum number, and therefore when n has a value of 4, 4 different subshells are possible. When n is equals to 4, the subshells correspond to equals to 1 or equals to 2 or equals to 3, and are named the S P, D, and F subshells. Then the maximum number of electrons that can be accommodated by a subshells is given by the formula 2 times 2L plus 1. Therefore, the S, P, D, and F subshells can accommodate a maximum of 2, 6, 10, and 14 electrons, respectively. All the possible subshells for value of n up to 4 are tabulated below. Notation: the electron configuration of an atom is written with the help of subshells labels. These labels contains the shell number given the principal quantum number, the subshell name given by the azimuthal quantum number, and the total number of electrons in the subshell is superscript. For example, if 2 electrons are filled in the S subshell of the first shell, the resulting notation is 1s to the power of 2. With the help of these subshells labels, the electron configuration of magnesium atomic number 12 can be written as 1s to the power of 2, 2s to the power of 2, 2p raised to 6, 3s raised to 2. Filling of atomic orbitals. Aufbau principle. This principle is named after the German word Aufbau, which means build up. The Aufbau principle dictates that electrons will occupy the orbital having lower energies before occupying higher energy orbitals. The energy of an orbital is calculated by the sum of the principal and the azimuthal quantum numbers. According to the principle, electrons are filled in the following order: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, and 7p. The order in which electrons are filled in atomic orbital as per the Aufbau principle is illustrated below. It is important to note that there exist many exceptions to the Aufbau principle, such as chromium and copper. These exceptions can sometimes be explained by the stability provided by half-filled or complete-filled subshells. Pauli exclusion principle. The Pauli exclusion principle states that a maximum of 2 electrons, each having opposite spins, can fit in an orbital. This principle can also be stated as no 2 electrons in the same atom have the same values for all 4 quantum numbers. Therefore, the principal, azimuthal, and magnetic numbers are the same for 2 electrons. They must have opposite spins. Hund's rule. This rule describes the order in which electrons are filled in all the orbitals belonging to a subshell. It states that every orbital in a given subshell is singly occupied by electrons before a second electron is filled in an orbital. In order to maximize the total spin, the electron in the orbital that can only contain one electron all have the same spin or the same values of the spin quantum number. Example, the electron configuration of a few elements are provided with the illustration in this subsection. Electron configuration of hydrogen. The atomic number of hydrogen is 1. Therefore, a hydrogen atom contains 1 electron, which will be placed in the s subshell of the first shell or orbit. The electron configuration of hydrogen is 1s raised to 1. Electronic configuration of oxygen. The atomic number of oxygen is 8, implying that an oxygen atom holds 8 electrons. Its electrons are filled in the following order. K shell, or 2 electrons. The L shell is containing 6 electrons. Therefore, the electron configuration of oxygen is 1s raised to 2, 2s raised to 2, 2p raised to 4. Chlorine electronic configuration. Chlorine has an atomic number of 17, therefore, its 7 electrons are distributed in the following manner. K shell, 2 electrons. L shell, 8 electrons. M shell, 7 electrons. The electron configuration of chlorine is illustrated below. It can be written as 1s raised to 2, 2s raised to 2, 2p raised to 6, 3s raised to 2, 3 5 raised to 5, or as Ne neon, 3s raised to 2, 3p raised to 5. Thus, a brief introduction of electron configurations is provided in this article. To learn more about this topic and other related topics, such as Lewis dot structures, registered by BYGUS.NL. That's our lesson for today. See you. God bless.